determining density. The objectives for this lesson is to discuss the terms mass and volume and their measurements. Everyone should be on page 18. I will read the introduction aloud as you read along. Okay? In this lesson, you will start to investigate a property of matter called density. To do this, you will have to measure the mass and volume of several different objects made from different substances. You will use the data you collect to determine the density of the substance from which the objects are made. Okay, let's turn page 20. Useful calculations. Now, we have already been introduced to density and its equation. Who can tell me what's the equation for density? Go ahead. Huh? Go ahead.
Equals mass times volume.
Mass times volume? Yes, ma'am.
Mass divided by volume.
Okay. Density equals mass divided by volume. Density equals mass divided by volume. Okay, so let's look at useful calculations. It says volume is a measure of the amount of space taken up by some matter. In this unit, the units cubic centimeters or millimeters are used when measuring volume. And also, you know, in the hospital when they say I need so many cc's of blood or cc's of that, that's the same thing as the cubic centimeter or the actual milliliter. It all equals the same. Because 1 milliliter equals 1 cubic centimeter, these units are interchangeable. The volume that something takes up can be measured in several different ways. A graduated cylinder can be used to measure the volume of liquids. The exterior dimensions of regular solid objects can be measured to calculate their volume. For example, the volume measured in cubic centimeters of a block can be calculated by measuring the block's length, height, and width in centimeters, and then multiplying those measurements together as shown in the following equation. So the volume of a block equals the length in centimeters times the height in centimeters times the width in centimeters, and that all equals the volume in cubic centimeters. Different formulas can be used to calculate the volume of other regular objects such as cylinders or spheres. Volumes of solids can also be measured indirectly by using a graduated cylinder. This method uses the displacement of water. Remember in our last lab right over here, we had the graduated cylinder and we measured out 50 milliliters of water, and then we put that ball of clay in there in the rectangle, and then we had to measure what point the water moved after those objects was placed in. That was the displacement of water, where you actually took the actual ball and the water and you recorded down what you saw on the graduated cylinder, and then you subtracted by the initial water, and you were able to tell the volume of the sphere. That was the displacement of water, so we're already familiar with that one. Remember, mass is a measure of the amount of matter in an object. In this unit, grams is used as the unit for measuring mass. Mass can be measured using a balance. We all have balances right next to us for this experiment or this lab. The density of a substance is the mass of that substance that fills 1 unit of volume. It is usually measured in grams per cubic centimeter. So let's look at our lab sheets. Now, in your boxes, you guys, everyone has a box. Take out your blocks that's in that box. Take out your blocks. Okay? So, who can go ahead and identify what those blocks are made out of? What is the silver? Raise your hand and tell me what that silver block is. Yes. That's the aluminum. And we have that written down in our chart. Raise up the aluminum. Everybody can see the aluminum. Yep, that's the aluminum. Okay, what's the next one on your chart? Yes?
Wax blocks.
Okay, find the wax block. Y'all know that wax, how wax feels like a candle. You can run your little nail over it. Does it feel like the regular wax? Okay. Which is the next one? Okay, and we'll raise up your clear plastic block. So we'll be all on the same page, no mistakes, okay? And what's the fourth one? White plastic. And does that one feel different from the wax? Can you scratch your fingers over that and flake it off a little? No. Okay? So those are the four blocks we'll be using for this lab. Now, before you start a lab, we always talked about the scientific method and how scientists go about setting up experiments. So for this one, we always said the first step of that scientific method, when you go into the lab, you either have to ask a question or state a problem. That is always the case for scientists. So we know what we need to do today. So we need to come up with a question before we actually start our lab today, before we find the actual densities of the blocks that we have there in the boxes. So let's think about it. You said we're going to find the density of each block, right? Who can come up with a good question for this particular lab? But we're going to find the densities of those blocks today. And that's what we want to know. What is a good question before we start the lab? Go ahead, Ivan.
Will all the blocks have the same density?
Well, all the blocks have the same density. Anyone else have a different question? That sounds like a pretty good one. Read that to me again.
Will all the blocks have the same density?
Will all the blocks have the same density? That's a pretty good one. Pretty good. Okay, so after you actually ask your question and you state your problem, now it's time for us to come up with our hypothesis. Now I want each table, since you're working together, each group, I want you to come up with your own hypothesis. Okay? But I'm going to help you. We're going to start the first part off together. Remember, your hypothesis is a if, then, or because statement. A if, then, and because statement. So let's see. What could we come up with for the if part of it? Let's come up with that together. Someone? Anyone you think? Yes, ma'am. If we measure, again?
If we measure the volume of the 4 blocks, then
If we measure the volume of the 4 blocks, then if we measure the volume of the 4 blocks, then, and this is the part that I'll let you guys work on as a group. So let's write this down. If we measure the volume of the 4 blocks, then, because that sounds pretty good since our question is, will all the blocks have the same density? So that's really good. Okay? So as a group, go ahead and start thinking about your thin part. And if you come up with your thin part, remember, what's the next part after that? Because we want to tell why. So our question was, will all the blocks have the same density? Now our hypothesis, which is good, start off. If we measure the volume of the 4 blocks, then you guys come up with that and your because. Okay? So let's go ahead and start with that.
Less dense one, bigger than the more dense one.
Just like the smaller ones have more density.
Okay. So guys, we said if we measure the volume of the 4 blocks, and you guys have 4 different blocks, right? Remember, to get you started, you can look at the different blocks to determine which one you want to use for your hypothesis, or if you want to use all. You can be like, if we measure the volume of 4 blocks, then 4 blocks will all have the same density because they are blah, blah, blah. Or you can use one of those, say one of these blocks. You can say this one has the most density because, or that one has the most density because. So if you're looking at your 4 blocks, what do you think? And pop up, please.
We thought that the aluminum would have the most density because it has a larger amount of metal.
Okay, so that's what you guys are thinking. That's your educated guess. So you're saying if we measure the volume of the 4 blocks, then
The aluminum would have the most metal.
the aluminum will have the most mass because
It's
it has
It's a larger amount of mass.
Oh, it has a larger amount of mass. That's a good one. I'll write that one down. I like that one. But we'll see if you're correct. We'll see if you're correct because we still have to test, right? Okay. Over here. So we said if we measure the volume of 4 blocks, then, so you guys had an opportunity to look at your blocks. What do you think will happen when it comes to calculating your densities?
We said that they will have the same density because the less dense ones are bigger than the more dense ones.
Okay, did y'all hear her? Okay, so you think that, say it one more time for me.
The less dense ones are bigger than the more dense ones, so they'll
Because
all be the same.
they're all the same. Okay. As long as you write it down and that's what you all agreed upon. Okay, so we'll go ahead and after that, we're gonna have to test it and we'll see if your hypothesis is correct. Hello, ladies. Hey, so we had, if we measure the volume of 4 blocks, what did you come up with for your thin and because?
If we measure the volume of 4 blocks, then they will have the same density because of their shape.
Okay. And you all came up with that together? That's pretty good. So we'll see if that comes true. We still have to test it. You will be like a true scientist. You'll see what they have to go through every day at the lab. Yep. Okay, ladies. So we came up with, if we measure the volume of the 4 blocks, tell me your thin and because.
We said if we measure the volume of the 4 blocks, then the clear block and the aluminum block will have the same density, and the white plastic block and the wax block will have the same density because masses of the blocks may make the densities between the pairs equal the same. Because we noticed that the volume of the white wax block and the clear plastic block look to be about the same.
Okay.
And although the clear plastic block and the aluminum block don't have the same volume, when you hold it, this one seems to be heavier than this one, so that may make it equal out.
Okay, so tell me your complete hypothesis one more time. Read it for me.
If we measure the volume of the 4 blocks, then the clear plastic block and the aluminum block will have the same density, and the white plastic block and the wax block will have the same density, because the masses of the blocks may make the densities between the pairs equal the same.
Okay. All right. So y'all really thought this one out. Y'all hypothesis is very detailed. Okay, we'll see how that works out once we test it. So you guys can go ahead and start with your measurements. True scientists over here. Good. Hello, guys. Over here. I'm going to talk to everyone. You know, we came up with the hypothesis here. We started off. If we measure the volume of 4 blocks, then because. What was your thin and because?
If we measure the volume of 4 blocks, then the aluminum will be more dense than the other blocks because it's metal.
Okay, y'all guys. Okay, say it one more time so I can hear you very clearly.
If we measure the volume of 4 blocks, then the aluminum will be more dense than the other blocks because it is metal.
Okay. Not bad. We're gonna see if that works out. That sounds good. Okay. So guys, remember, you have to utilize everything in your boxes will help you. You have your trusty ruler. And remember, we said we're measuring in cubic centimeters, so remember to use your centimeter side. And on the end of the tables, you have your balances, so make sure It's on grams, and we're measuring our blocks. Okay? Okay. We have up there for you to get ready. So you might want to just go ahead and start with your doing your blocks first. Get your rulers. Okay. And we have extra rulers up here.
The height is this, the length is this. This would be 5, this
Okay, so what you was measuring your width?
Thought that had it at the end.
It is. I'm off because it's
So the aluminum is the 2 centimeters in length, and then height is 4 centimeters, and it's 18.3 grams.
Isn't it good to already know how to calculate your volume? You guys have been doing this now for the last couple of years. Well, your volume since like 6th grade, right? That length time, that width time, that height.
What was it?
So y'all working with y'all transparent or clear?
I do it. Yes, ma'am. Which one? This one.
The transparent one.
I already measured that way.
Guys, remember we have our set of calculators over here.